Good morning, everyone. My name is Alexis Dacquay. I'm a systems engineer at Arista Networks, covering EMEA, based in the UK, French, but based in the UK. We're going to talk about today the network visibility, gaining back visibility in the network, and in particular for networks full of containers, VMs, and a lot of clustered compute. So if I may ask a first question in the audience, how many people here would consider themselves on the networking side? Okay, and the rest, is that application or server? Server? Okay, thank you. So one thing that you have to understand is that the network operating system, the software architecture, is fundamental to keeping pace of innovation in networking. Network is not just a few ports in a box. This is about the operating system. And that allowed, with that EOS, the Arista operating system, that operating system foundation allows Arista to outpace in programmability, in openness, and scale, and visibility. So we're going to discuss a bit about what EOS is. EOS, the E of EOS stands for extensibility. This is an open architecture. What you see in the picture here is a central state repository in the operating system. What that means is that every single process, and maybe the networking team here maybe don't understand what an agent program is, but maybe the server teams, the application guys, we understand maybe Linux. Among everyone here, who understands Linux? Linux fans? Okay, cool. So the operating system is based on a standard unmodified Linux. All the competition traditional networking equipment modify heavily Linux to add, to reprogram the TCP stack or some old branches. But this is exactly the same distribution as you find from Fedora. Unmodified means everything is loaded in user mode. We don't do anything in root. That allows the EOS to be very scalable from the kernel. It's not our branch that's exposed to just a few hundreds or thousands of devices. This is the same kernel that you use on millions of servers. You can see on millions of servers in the world. And then that allows EOS also to be very extensible. You can load some RPMs on our switch. You can run bash, Python script. You can install the libraries you want. You can do a yum if you want. So this is a very programmable switch. If we go back to that state repository, this is the way all the agents, all the processes are communicating with each other. There is no IPC, inter-process communication. Everything is a publish and subscribe model, where when an agent has to detect, for example, I will make it understandable for the networking team. I will take the example of spanning tree. When spanning tree has to update a state, such as port 1 is forwarding or blocking, when it changes from one to the other, is going to push that from that spanning tree process to the EOS, the NetDB. That state will then be propagated in real time to all the other agents that need to learn about it, such as OSPF to do some convergence, or Snmp, and so on. So this is a real-time publish and subscribe model, but without direct interaction between the processes. And this is a huge scale advantage, because when you have 50 different processes, it's getting very complex to develop and to keep scalable an operating system when all processes communicate with each other. So this is hugely scalable, flexible in terms of operating system, very reliable, and us as Arista company allow us to deliver you a huge agility in the software development. So that means software features faster, easier. All the different processes are decoupled from each other. There is no direct interaction, much easier to develop, to troubleshoot, and fix. And we've got on the bottom different hardware platforms. We've got 30 different hardware platforms from different silicon, totally different chips, but this is a single binary across all the network, so providing that hardware abstraction. And on the northbound, so on the north side of the operating system, you've got multiple APIs, programmatic interfaces. From XMPP, you might know it's eJabber, the eAPI, so JSON-based, structured HTTP, RESTful, Google Protobuf for streaming. There is OpenConfig, the new API standard. There is an SDK. You can program in Bash scripts, Python script, but also C++. You can hook your own binaries inside our operating system to access directly that centralized NetDB state. Program directly in the hardware. We've got a lot of different visibility tools, and that's one of the points of this discussion today. How do you gain that visibility? It is thanks to that operating system that gives you a lot of different tools. One of them is a container tracer. So among the server teams, you probably know about container. The network team maybe not, but the networking team will know about VMs. So maybe what the networking guys don't know is that the server guys in the are looking into containers, moving away from VMs maybe, because it saves resources on their compute. And what we provide here is container tracers, allowing the networking team to see on their compute nodes what containers are running, what applications. Not control them, just view. Because when there is a problem somewhere, the networking team is involved and need to troubleshoot. Because the networking team here might have heard the word the network is down. That's because of the network, right? So you have to prove, you have to help the application owners to troubleshoot that. That's allowing you to do that much faster. Such as, no, that application is not in this rack, it's in another rack. Docker, as a modern virtualization platform or way to deliver application, can be delivered on the compute, on the servers, but also on the Arista switch itself. So the way the server team, the operational team, want to manage their IT infrastructure might be using containers to deploy applications. You can deploy the same applications, the same containers on the servers, but also on the Arista switch for managing tool, for monitoring, for example. There are new programming language. We support Ruby, we support Go, Python, and all the Bash. You can install your own libraries if you want. Networking team might recognize some of those entries. That's Arp Table, MAC address table, routing entries. One thing that you get from a networking device is, in its tables, the current state. Such as what MAC addresses have I got right now, what IP addresses, so on. But what did I have a second ago, or last week? These entries here show that every state change is being recorded locally, and we will see later is also being streamed out, so that you can have visibility, not just on what's the network like today, right now, but how it was whenever it changed an hour ago, a week ago. So that when you troubleshoot something because it doesn't work, you know how it looked like when it was working, or maybe you see the changes that the server guys did. Maybe they swapped the servers and it's a bit different. You have all that visibility. The MAC addresses moved from one port to the other. The ARP resolution changed. You've got all the different state changes in the network being recorded. And all the switches with the NetDB can stream it. Streaming with Google Protobuf. This is an open standard. You can choose some other mechanisms if you want. And you can stream it either to an Arista Cloud Vision, where we provide that database to store that, or your own. Because you can use netconf, Google Protobuf, you can use gRPC, HTTP, or your own mechanism for streaming. You can write a Python script, or a Ruby script, or a C++ binary to stream that information out to one of your server, to one of your controller, where you can consume all the states that are in the Arista EOS, meaning all the tables, all the logs, all the counters, real time. So that allows you to have a visibility of the whole network and move onto the historical data for all the network. So traditionally, you've been monitoring network using maybe SNMP, polling the MIB every few minutes for some entities in the MIB. That's very restricted to only a very small amount of information in the switch and at very large interval. So it's not giving you the granular visibility. It's poll and miss. You miss for 4 minutes, 4 minutes 90, 4 minutes 59 seconds, and then you poll just in a second what's happening. That doesn't give you visibility. It's a very poor visibility. With this, not only it's lightweight, scalable, because it's streaming. If nothing happens, it's not going to stream anything. But when state changes, when something happens, then it sends you a notification. So very lightweight, very scalable. And again, fully open with using all the standards. Another thing that the networking team will know is about buffers in a switch. Well, I hope you do know about how you're losing packets. Why is the network dropping packets? That's because the buffer queue is full. There's tail drop. There is tail drop when there is micro congestion. You might have 50% utilization, but that can cause drops when there is a sudden incast or speed difference. And that can be visible with LANs. The feature is called Latency Analyzer, because guess what? When packets pile up, it causes latency. But the important point is it's trigger-based. Upon exceeding a threshold, that can be as low as few as just 2 segments, then you will have an event being recorded. And some platforms can even stream the packets that are causing the congestion so that you can gain visibility on not just, I've got congestion, but, oh, this traffic is causing congestion. You can capture it on the switch itself, write it as a pcap, or send it to an analyzer. And what that gives you in knowing the exact buffer is this. You've got a network map with heat maps of different buffers in a network. Today, when a network, when you don't receive alarms, what you see is that. You think everything is okay because you don't receive red alarms, because you are not having drops. But actually, you might have some hit, some hot spots somewhere where you have congestion, or because maybe you've got 40 gig or 10 gig uplinks sending traffic to the switch and everything down is just 1 gig. Or maybe all your compute is sending traffic to your storage. How is buffer management on your switches? So LANs give you that visibility. On the virtualization side, the networking team will know that VMs are being popped up in many different places. And there are 2 ways to allow that communication for the VMs. Either you allow all the VLANs on the trunk towards the hypervisor, or, because you are a bit control freak, or possibly rightly, you only open the VLANs when you receive a ticket from the server team, from the virtualization team. But then they have to wait for you to be available. You can't do it when you're on holiday, for example, or when you're off sick. So this is a lot of laborious tasks, or potentially something you don't really like, having all the VLANs open on all the trunks, because you've got effectively a flat layer 2 network for your 4,000 VLANs on your network. And you don't know whether the virtualization team might bring a VM on the wrong, maybe on the DMZ VLAN instead of the internal one. So what VM tracer allow you to have is first auto-provisioning for the VLANs, the trunks, and also you might know NSX and this service chaining. But importantly, from the CLI, from the network device, you can have visibility about what VM reside on what, and behind what port on which hypervisor. So then when there is an issue, when someone raises a ticket because either make a change or where is my VM? This customer is complaining about the Exchange server not working. Well, you can have a look and say, instead of asking, okay, what's the IP address? What's the MAC address? Maybe the client doesn't know. You need to figure out, you need to communicate with the virtualization team, the server team, where's that server? But with that, you know directly that the Exchange server is on this VM, has got a VNIC, and is on the VLAN 7, which would be port group 7, for example, with VMware. But maybe it's not an allowed VLAN, maybe it's not configured anywhere, maybe they mistyped, it should be 7.7, for example. So you can very quickly have visibility about what's going on the virtualization side. Who knows about containers? Okay. So maybe just a quick overview. Arista is involved with Docker containers in 2 ways. One is allowing you to run containers on Arista EOS. The second one is with Container Tracer, allowing you, just like VM Tracer we've just seen, allowing the networking team to have visibility about what containers are running in the data center. So the first thing is, what are containers? Containers are, it's a way to conveniently package the application, removing some of the, removing the dependency issues. Dependency means that a specific application needs some libraries. And this is also the most important why the server team, the virtualization team are looking at it. It's because it removes the resource stacks. So the amount of resources that VM consume compared to the container is enormous because VMs require their own operating system. Each VM will have its own operating system. Containers run directly on the operating system. So it's very lightweight to run applications. Then you've got some kind of app store with a Docker Hub, for example. But the main point is light on the resources and ease of distribution, because there is no dependency now. An application that works on one container will work on all the containers. That allows the DevOps team, and now I'm talking about both the server, the operation guys, and so network server and ops, because the new generation involves more communication between the teams and bringing a bit of automation. And the application that now can be deployed on the server can also be deployed on the network devices for automating, for managing it. So for example, you can load NetTools. It's a container running SFlow tool so that you consume the SFlow data directly on the switch, fping, hping, nmap, netcat, and so on. You could already install it as an RPM on our switches I mentioned earlier on the kernel. But remember, the advantage here is that there is no dependencies. Whichever operating system version you will have from Arista EOS, it will just work. Whether we upgrade it, whether the libraries are changing, it doesn't matter. It will, in the container, it will always work. So for OSS teams, for DevOps team, it's much faster to develop applications for the network, for the IT infrastructure, to test and to put in production. Now into the container tracer. Container tracer is an addition to, we mentioned VM tracer. We also have map Hadoop tracer for big data that also traces the big data, the map produce and mapping across your big data infrastructure. So this is for gaining visibility inside your workload in your data center, as well as inside the device's different tracers, link, path tracer. Now for container tracer, what it allows you to do is to see on which port in your network, Ethernet 13, for example, is connected to a compute. I put it in bigger here. So you've got Ethernet 13, Ethernet 15 connected to NNX 150, NNX 151. So you can see on which computer, which server the containers listed here are running. And you can see what application the containers are running on what layer 4 ports they are running. So that gives you visibility, being able to troubleshoot faster. Just networking team gaining visibility on the workload. Who's heard about OpenConfig? OpenConfig? Who's heard about netconf? Yeah? So what is OpenConfig? OpenConfig is relatively new, a new way to program and access, gain visibility on the device's configuration. It is driven by big cloud companies, Web 2.0 companies, service providers that want a vendor-neutral API, programmatic interface, to configure and extract information from their network. The goal is that must be vendor neutral, but also very explicit in its definition, to be very scalable. So OpenConfig was brought up because there's one thing that all the other APIs or standard didn't provide, is that the data model was not standard, was not universal. And what do I mean by data model? Well, data model is the information stored on the switch. This is, for example, the IP addresses, this is the BGP peer, this is, all that information is stored in a way that can be consumed by system, computers, or human, with CLI commands, for example. And then you've got the protocol. The protocol is the way to access that data. So in an example of data model, there is the MIB. And an example of protocol, there is the SNMP protocol. You probably all know that Snmp is not very, has been there for ages. It's not very suitable for configuration. They had improvement into the authentication for security purposes, but it's not very scalable. It's not very efficient. I mean, we talked about polling every 5 minutes. Can you imagine polling every interface on your network, every second or so, or doing a MIB walk every minute? It just doesn't scale to have a more granular view on the network. So some vendors brought some APIs to allow a more programmable network. One of the problems is that those APIs were dependent on what kind of information was available on the network device and how initially that data was stored. We talked about NetDB on the Arista EOS, and we just presented the data that was on that NetDB through our JSON RPC-based API. In this example, you can see in the middle row, there is, for LLDP information, there is, for example, port on an LLDP neighbor. The port variable has got the value of Ethernet 1. Or maybe a Cisco device. Well, one of their OS might have L_port_ID, and the value will be ETH 1/1. So when a customer wants to program the network, how do they convert their controller towards, on one side it's port equals something, and the other one is L_port? They need to do some parsing, they need to use regular expression, they need to do some translation. And this is even different into another Cisco operating system and other vendors. So there was no consistency. And then we go to the protocol. There was netconf, there was restconf, but those are just the protocols to access the data. You can use netconf, but you still don't get the same presentation of that data. The way the data is structured and presented to the protocol is different between different vendors. So although netconf, restconf are standard, they are not resolving that data model consistency that will allow that customer to access the data and program the network in a consistent manner. So netconf, restconf did not resolve that. And equally, there was Yang. Yang is a data model. You can think about XML exactly the same way. You can use Yang or XML, but that still does not dictate how the LLDP port must be presented to the protocol. So Cisco implementing Yang would be presenting data in a different manner than Juniper with using Yang, and different from Arista presenting Yang. So still doesn't resolve that. So OpenConfig is a method of using Yang, but the data model, the structure, is being explicitly defined by OpenConfig, by the customers. This is Google, Microsoft, Yahoo. You can participate in the definition of OpenConfig to force all the vendors to present the data in the same manner. So instead of one having port, the other one L_port, we can define that an LLDP neighbor should be called just port_ID, for example. And then the vendors have to implement that. The protocol used, you could use HTTP interfaces, you could use netconf, restconf. Again, that's just the protocol. The Yang is the way the data is modeled, but netconf is specifying very explicit definition of those data structure. To move away from a vendor-specific data model and legacy protocols to a vendor-neutral data model where we are still using standards, but the standards are not just superficially named, it's not just using the standard name. The actual implementation is really standard and allowing the customers to access the data in a universal manner and still being flexible and scalable. For example, you'll have BGP routing policies, you will have interfaces. Those are different data models that you can see on GitHub. So all the OpenConfig data models are available on GitHub. What I'd like to propose you now is to run some demos. Some demos about what I've just talked about, OpenConfig, about the streaming of states, and Docker. I'm just going to increase that slightly more. Can everyone see on the back? So I'm on the Linux server, and what I'm going to do, we'll start with the OpenConfig. What I'm going to show you here is that I'm on a switch that has got, it's a layer 3 switch that's got some uplinks, layer 2, layer 3 connectivity with IP addresses on the interfaces. And let's say you've got some automation tool, or you are thinking about doing something, you want to automate, you want to send configuration with OpenConfig. Let's see how you can also extract information about that configuration, check the configuration. So here we've got layer 3 interfaces, and let's say we want to configure BGP. So router BGP, what AS number do you want me to use? 666. So Shractive, I've got my router BGP, and I'm going onto the Arista. It's just a Linux platform here from where you could send your instruction or gather things with OpenConfig. I'm going to run a get. So just getting the BGP. So there is a specific path that I can look for. I could look for the interfaces, the IP configuration. Here I'm looking for the BGP. And you will see the AS number here, 666. Okay. That's not very, it's difficult to read, so there's another prettier way to do it, is just in a beautified, human readable, where you have that information. There's also another way to see that. It's in a more structure. I'm just going to do show you how you can get things even better. So I'm just taking an example of a website. You've got some local applications, if you want, clients. You can select all that output, just paste it there. So what we did in CLI was just this beautify aspect, just to be human readable. You already have the syntax highlight on the left. And what I'm going to do here is just the tree view. I'm zooming in because I'm conscious it's a bit small to view from the back. I'm collapsing everything, and I'm going to show you, this is the structured data, and inside the configuration here, you've got the AS number that we have configured. So different way for a human to look at all that information, but naturally it will be typically just programmed using scripts or a controller of your choice. The other thing we are going to do is we've just configured manually some CLI commands. We use netconf to extract information to see how it was looking. Now what we're going to do is we're going to configure something with OpenConfig. And to look at that, we're going to push, it's already structured JSON. We're going to look at this file. This file is already pre-formatted in JSON format, luckily for us, human readable. And you can see that we're going to push some new AS number, 3841 instead of 666, with some router ID. And we have also, further up, some BGP neighbor. So we're going to configure some peering. Okay, as an example. So I'm just entering that. The command is just sending the JSON file by with OpenConf And what I'm expecting here, run section router, is to have my BGP configuration with the new IS number, with the router ID, and with the two neighbors. I'm just going to recheck by openconfig what I've got. So this is a much bigger output, but we can already see who can spot the 3. Well, probably like me, you can't see anything out for it. This is made to be machine consumed. So as a good human, I'm just going to use a beautified display where we've got that, or even more readable, the tree view. I'm going to collapse just to have better visibility. I'm opening the config, and we've got here our AS number with the router ID, and further down we will have the neighbor configuration. With, you can add route maps. So this is our neighbor IP address. So what I've just shown you is openconfig, the new API, that's the new standard for being really universal across multiple vendors. RESTconf, NetConf, API, they are just protocols. What matters is how the data is structured. So openconfig being driven by big companies, but that you can all benefit. Any question on openconfig? Yes, question? Hold on a moment, let's take the microphone so that everyone can hear.
Do I need any special configuration of the router itself to use it?
So, I forgot to present Arista. We are a networking vendor for the data center, mainly selling data center switches, layer 2, layer 3. But although we do have some products that are, we've got a full BGP table and switch router, it's a bit like bridge switch, where is the distinction between switch and router nowadays. So openconfig will be available on all the different platforms. We already have, we've seen in EOS, we've got dozens of APIs that will be just yet another API. But we've got a single operating system for all the platforms. So across 30 different hardware, whether it's 1 gig, 10 gig, 40 gig, 100 gig, fixed modular chassis, that always the same operating system, so you will be able to access any device exactly the same way. Does that answer the question? So the next thing I was going to, was there another question? The next thing I was going to present now is Docker. Because Docker, as part of the extensibility, deploying application, lightweight or a bit more heavyweight on the switches, allow you as a networking team to be able to do more with the switch in terms of automating, allowing integration with orchestration, service chaining, making things more efficient. So Docker is showing me here that I don't have any container yet on the switch. By the way, this is a switch, just to prove it. So this is my switch, okay? But there's a Linux kernel, I can access the bash. This is from where I will be driving Docker, okay? And that Docker info tells me that I've got no container yet. And if the Wi-Fi connection works, then I will be running a hello world. You can see, I don't know if you've noticed, but there was a very quick download. It says there that it's not available locally, so it's putting it from Docker Hub. Then executing it, it just says hello world, as a proper hello world, with some instruction, including challenging us to do something a bit more ambitious here, which we are going to do. We're going to run a Docker of an Ubuntu version. I'm going to run an Ubuntu container on the Arista switch, so that maybe your favorite application is a Debian package. It doesn't run as an RPM, it doesn't been compiled. And you don't want to have to compile it for different kernels. You just want a container easy to deploy, easy to develop, and to test. I'm going to use this, for example, and I'm going to get into bash. So what it's doing, I've just specified the application name, is going to Docker Hub. Docker Hub is a kind of the app store for the containers. The enterprises can have their private hub to have a secure environment to deploy containers. After downloading it is just extracting it. It's obviously a bit bigger, but you can see that the size of that Ubuntu container is just 65 megabytes compared to what a VM will be. Even if you take the Linux, the Ubuntu core of a distribution, that will still be much bigger than that. So what we have now is, I don't know if you realize that the prompt changed. We were previously on Docker switch. Now we're on something else. And that something else is the Ubuntu release. So we are now on a Ubuntu 4.14, where you can have all your Ubuntu application. apt-get, you can do whatever you want. Very easy to deploy things, purely standard. And if I'm exiting that, I can check the memory space, because we talked about 54 meg. That was the disk space. But now we're going to look at the memory footprint. And you can see that the memory footprint, what's being used by Docker with one container, the hello world is just less than 1 kilobyte, so it doesn't matter. But this is an Ubuntu running into just 200 megs. While previously a dedicated VM, would consume much more because it had yet another kernel on it. So much more lightweight. That allows it's very easy, it's very powerful. Most of I don't know if you've got DevOps team developers, if the server teams are doing that, but many different companies are looking into that. Any question on Docker? So the point is ease of management on your network. The last thing I'm going to do is to show you the state streaming. Because again, that's very powerful to have a complete visibility of not just one switch, one by one, polling each switch every 5 minutes, or every minute if you want. You can poll your switch every 10 seconds. A MAC address might flap, 50 times, you might have a problem. It might flap 10 times and then be quiet. So when you're just polling every now and then, you can just miss everything. So I'm going to run the demo. What we're going to do is check the Arp tables. So I'm going to stop that because there is just a heartbeat that keeps scrolling things, but you have noticed that there was no additional update. What you see here is the content of the Arp table being streamed by one of the switch. We're looking at the Arp. We've got from, I'm just going to log on to my switch called lif1, show Arp. So we can see that this is the Arp table on that switch. It's got 4 interfaces, 4 uplinks at layer 4, Ethernet 1, 2, 3, 4, with MAC addresses, and these MAC addresses are translated in a computer. It's just digits, it's just numbers. That's the word, that's the octets, the different octets for the MAC address on Ethernet 1, for Ethernet 2, and Ethernet 3, and so on. So what it does, initially it pushes the first update, the first notification, and then there is no change afterwards. So it's just waiting silent. And what we're going to do, we're going to trigger a change. So I'm going to shut down one of the interfaces to see that change. I'm going to run that. So I've got 4 interfaces here. Which one do you want me to shut down? The management interface. No, next. Number 4, thanks. In the last event, they asked me to shut down all of them. So I'm going to shut it down and we'll see what we look on the streaming. So I'm going to stop that. You've seen that little update here. What it does is you've got another notification. You've got a timestamp. You've got a notification. The notification, the previous one was an update. Now it's notification of a delete, remove the entry. And the entry is for everything that was under the IPv4 with the IPv4 address here and Ethernet 4. I can retrieve it if you want, but it was Ethernet 4, so it deleted everything that's all that content here. Okay. And what I can do now is, if you want to see it back, I'm going to do a no shot. So the stream is providing brand new information, notification, update. We've just learned that new MAC address, and this is the 3 different octets. That's available for everything on the NetDB inside the switch. All the tables, all the logs, and also the counters on an interface. Here I'm monitoring, for example, interface 2. So there is a bit of traffic, there is a bit of BGP, sometimes it's quiet. When there is just heartbeat, it means nothing happens. And then when BGP is speaking, it will increase the counter, then it will send an update about, oh, that counter has been updated. Okay? When there is no increase on the counters, there is no update to be sent, it's just quiet. It's just the heartbeat. And then we've seen earlier, so I could look at some of the interfaces, it's a bit quiet. Here we have. So when there is an update, then it's updating the parts of the counters that have been updated. But it's not just that part, it's not everything that's updated. You can see that there is a much higher amount of information located for that as counter for that particular interface, but not everything is updated. That's the whole thing here. That's the initial update. Later on, just some subparts are being updated. So this is the most efficient way to gather information on a switch, where you just receive streams of updates as they happen, for gaining visibility on all the tables, all the states on the network, and all the counters and logs, consuming that in a open format. So that was all for my presentation. Is there any question? Wait a bit for the mic, please.
So actually there's 2 questions. First one is, did Arista made any changes to the Docker itself? I mean, the security of the Docker. So this is like still the C groups and everything. And like a follow-up to that, what would happen if, for example, one of the Docker images would hit your kernel and you're gonna restart? What would happen to the switch?
So sorry, the second question, what happens if one of the application?
Yeah, so what would happen if one of the Docker, let's say, will kill the kernel for whatever reason? Mm-hmm. I've seen some information out here about out of memory is disabled or something like that. So what would be possible impact?
I will say that, so the first question was, have we modified anything in the kernel? Because it's a standard Linux distribution based on Fedora packages, there is almost nothing we need to do to make it available. There are some little, we distribute it, but no, that's why it's so easy for Arista to implement new feature. And I was talking initially about how we outpace in terms of innovation. The second part is, can a container crash the switch? Well, I would say it's a bit like you could put a VM before. You can go into bash. I can do a, rm-rf on the root if I wanted to, because I gave myself the admin right. So if you don't trust someone to do a shutdown on the interface or to do a reload or do something in the kernel, don't give them access. Just like for any VM scripts or RPM, you don't get them from repositories you don't know. You validate them in lab and you make sure that they work. So before pushing them in, even if you trust them, before pushing them into production, you use US Lab. So all the demonstration I've shown you, it's running on VMs. Virtualized Arista iOS, because it's on a kernel, it can run on a VM. It hasn't got 100 terabit per second of throughput like the real switches or hardware TCAMs, but all those features are software features, universal. So I would say I get that hello world that I don't trust in a VM, I run it, I looked into it, I tested, validated, you can build virtual topologies, is it working? So just like you would do for any application in your production. It can, but just like any server can crash because the application was written poorly.
Thank you.
Any other question? So if you want to just have a one-to-one, we can discuss at the Arista booth. Thank you very much.